even function has the form f of x negative x equals f of x. What that means is anytime you put a negative x in, you get the same answer as if you put a positive x in. For example, the function f of x equals x squared is even. Why is this even? Well, the reason is if I put negative x in, so f of negative x, that's going to be negative x all squared. And when you square negative, you end up with a positive. So f of negative x is going to be x squared, because negative x squared is x squared. And so f of x equals x squared is an even function. The graph of an even function has symmetry about the y-axis. So for example, the graph of y equals x squared, or f of x equals x squared, is symmetrical about the y-axis. The y-axis is an axis of symmetry. And we can see that here. The right side of this function looks the same as the left side. And so if we visually see that, then that function is even. Okay, odd functions. An odd function has the property f of negative x equals negative f of x. And what that means is if I'm putting a negative x into the function, the answer I get is the negative of if I had put in the positive x into the function. So for example, let's say we have f of x equals x cubed as our function. Well, let's say I put in negative x. I want to know what f of negative x is. Well, that's going to be negative x all cubed. But if you cube a negative, you end up still with a negative. So that's going to be negative x cubed. So f of negative x is negative x cubed, which is the negative of the function. And so that means this function is odd. Graphically, when you graph an odd function, if we look at y equals x cubed, graphically when you graph that function, it's symmetrical about the origin. So we could see, in this case, there's symmetry between quadrant 1 and quadrant 3 for this graph. If the graph had symmetry between quadrant 2 and quadrant 4, it would also be an odd function. Let's take an example of the function f of x equals the absolute value of x. We want to know if that's an odd or even function. From the graph, we can see that that's the graph of a v, which is symmetrical about the y-axis. Therefore, just looking at the graph, we know this is an even function. If we try the algebra, remember for an even function, if you plug in negative x, we want to know what f of negative x gives us. Well, that's going to give us the absolute value of negative x. And the absolute value of negative x, remember, absolute values make everything positive. That's just going to be the same as the absolute value of x. So f of negative x is the absolute value of x, and that's also equal to f of x, and that's why we have an even function. Now let's take something a little bit more complicated. Let's say we want to know if f of x equals x times the absolute value of x. Is that going to be odd or even? Well, before I graph it, let's plug in f of negative x. F of negative x gives me negative x times the absolute value of negative x. So we plug in negative x everywhere there was an x. And what happens there, remember, we still have negative x, but the absolute value of negative x is the same as the absolute value of x, because the absolute value makes everything positive. So we end up with negative x times the absolute value of x. That's what f of negative x gives me. And that happens to be the negative of this function. So therefore, this is negative f of x. It's the negative of the function. It's negative x times the absolute value of x. Now, if we were to look at the graph, we can see that, we can verify that with the graph too, that graph looks something like that. And so there's symmetry across the origin, and therefore this is an odd function. Here are some more examples of even and odd functions. Let's look at this function here. This function here is the sine wave, and this function is actually odd, because we would see that there's a symmetry between quadrant 1 and quadrant 3. Here's another example of a function. This function here is the cosine function. That's what it looks like on the positive side, and this is what it looks like on the negative side. So the cosine function is even, and you'd see that in trigonometry. Some other examples are a straight line that runs through the origin is considered an odd function because there's symmetry between quadrant 1 and quadrant 3. Also, if you have a function that looks like this, is symmetrical, again, across the y-axis, that would be even. Now, not all functions are even and odd. Sometimes a function is neither. So let's take an example of a function. Let's say f of x equals the absolute value of x minus 2. Now, we already know the absolute value of x is an even function. But what about the absolute value of x minus 2? If we were to graph that function, that looks like the absolute value function, but it's moved to the right too. So there is symmetry around x equals 2, but it's not symmetrical across the y-axis. So in this case, this function would be neither even nor odd.